When broadband internet access began eclipsing dial-up in the early 2000s, it was an entirely new way to experience the internet, and a holy grail if you didn't have access to it. I've always been perplexed as to how cable modems work in the first place, so today I'm going to get a broadband ISP setup right down here in my home lab, covering some theory of operation, physical setup, and finally getting more than one early 2000s cable modem hooked up over one coax line. We'll also take a peek inside that massive broadband router and take a quick look at its configuration. Let's get into it. This is a sneak peek of where we're going to get to in this video today. This big router represents a broadband internet service provider right down here in my basement. So you can see it's sporting some coax connections. We're running through some splitters and filters, ultimately to two early 2000s consumer cable modems. As you can see from the LED indicators on both modems, they are happily connected over broadband up to that router. And in fact, they each have a distinct IP being given out by the router, accessible to computers that you plug into them. If you have broadband in your house today, it's basically the same setup. We're just using some early 2000s gear. But to create your own Homelab broadband ISP, we must first invent the universe. We're going to talk through what's going on with these filters, these splitters, how the coax connections flow into this router, what's special about this router, how the modems work, all sorts of stuff relating to broadband, and how this setup is working. We'll start with this Cisco router. This is a Cisco UBR 7100 series, and you can see it is quite a bit larger than some average Cisco gear. The UBR stands for Universal Broadband Router. I think this thing came out in the late 90s, though I'm not sure when this exact unit was made. Maybe we can find some date codes. But judging by the vintage of Cisco logo used here on the front, I'd say late 90s is about correct. And if we flip it around, we can see where it gets the broadband name from. It's got tons of these coax connections, which we will dive into and explore. It's got this main control module that isn't removable. It's got the console port for terminal access. That's how we'll configure it over a serial connection. Specifically, this is a UBR 7114. It also comes built in with two fast Ethernet ports, which is really nice. We'll be using at least one of those. And it's got this absolutely heavy-duty metal enclosure for the PC MCI flash cards where you store configuration on. Let's open that up. It uses a flathead screw, even though everything else is Phillips. Yeah, a little door hinges up, and we've got two of these flash card slots. Inside we've got some pretty typical fare, a Viking 24 megabyte card. So this is where you would store the configuration of the router. And it's these are keyed, so theoretically you can't put them in the wrong way, but the plastic's pretty soft and you can kind of jam them in any way you want, really. I've had issues with that in the past. And the door even reminds you, insert card with text facing this direction down. Get that back in there. And then over here is something that really excited me about this router. That is what's called a port adapter slot. This one right here. This was used in the 7200 series of routers. The VXR routers are some that folks might be pretty familiar with. They were really popular in the late 90s and well into the 2000s. It's got this little protector door thing here. And then yeah, this is a blanking plate, of course, but that is a port adapter. Here's one of these VXR units I was talking about. So clearly its main module are these port adapters. So you could pull one out and slide one in here. While I was messing around, this is a E3 card, which is apparently the European version of T3. Sure enough, on the back, it's got some markings about the United Kingdom. Why do I own this thing? There's actually a UBR broadband capable unit in this VXR line, which I actually really wanted. A huge inspiration for this video were the broadband and DSL videos that KJ7BZC put out. They've got one of those cool VXR units, but they're very, very heavy. So, you know, hard to come by, hard to ship. And they're missing some RF tricks that this one can do that we'll get into that actually ends up saving you a little bit of money. And that's why I went this route. But anyway, it's awesome that this is a port adapter, which means you can do all sorts of exotic stuff. This is an ATM card that an ISP, I don't know, might be using. It's funny, it's very easy to get these into the VXR units, but very hard to get it into this one. They did not do as good of a job. I can't even get it in. Let's open this thing up. Looks like just a few Phillips across the front. It must have some user serviceable parts in here. Otherwise, Cisco makes it very non-obvious how to get into their gear. Oh yeah. At the very least, it looks like we can upgrade some RAM right here. And there's something else here. This is a flash sim, so more flash storage. Look at those beefy power connectors. Wow. Anyway, here's the problem with this port adapter. There's rails here that this slots into, and that's all good. But then the card has the ability to really move around by the time it's hitting the back, and it's like really hard to line it up just right. It's very easy to just be way off, so it's in there now. But yeah, that wasn't going to be easy at all with the case off, and I'm really wrenching on this connector. I don't like that at all. But anyway, we're not going to use that. Kind of interesting to see what it looks like when you're sliding this stuff in while the lid's off. Not much else to say in here. Some RF and coax stuff, no doubt. Riser board for the port adapter has a really nice Cisco Systems logo on it. And at the far edge of it, I'm seeing copyright 1998. So yeah, we'll call it late 90s. That's the physical overview of our UBR router out of the way. But now we need to talk about how we're going to use it. So we're going to leverage two of these coax connectors to deliver a broadband connection to a handful of cable modems I have using something called DOCSIS, which stands for Data Over Cable Service Interface Specification. DOCSIS was and is a standardized way to deliver internet data over existing coax lines that were already running to many homes, at least here in the United States. This is a pretty old router, and I've only got pretty old modems. So this only supports DOCSIS 1, maybe also DOCSIS 1.1, basically download speeds of 40 megabits per second, which doesn't sound like a lot, but when you were going from dial-up, which was operating at about 33 kilobits per second, best case scenario, usually lower in my experience, 40 megabit potential was just astronomical. Now these are of course called cable modems because the internet and data and voice and everything else comes over this cable, as in cable TV, probably. So this was probably already serving your house with cable television. DOCSIS is a standard that lets data flow over this. So why even worry about these things in the first place? And why this one in particular? Well, this was, not the exact one, but this exact model is the first broadband modem I ever had. My dad got broadband internet, my mom still had dial-up, and this was the modem that he got. To me, this represents like a door opening, like finally getting access to be able to play as many games online as I wanted back then. That was really important back then. Medal of Honor, Allied Assault, Counter-Strike, Return to Castle Wolfenstein. Like when I look at this, all of that floods back, hours and hours and hours spent playing with friends and my younger brothers online, and just being able to like surf the web comfortably. We'll do a bunch of speed tests later looking at this thing and just how much better it was than dial-up. And a lot of people, at least in my area, were making the jump from dial-up right to this. So that was a massive improvement. And something that always fascinated me is how is all of that happening over a cable like this? For example, an Ethernet cable, you know, it's got 8 connectors, all the wires inside, something, you know, a little crazier like this, tons of different pins, even a serial cable, a ground, a power, there's some data pins in there. I'm not an electrical engineer, I'm not a protocol designer, but if you locked me in a room and gave me one of these cables that have tons of different pins on them, eventually I could come up with some sort of protocol to transfer data over them. Like I can visualize how that might work. But this thing, this connector, that connector, we're talking like 2 wires basically. How's that work? Little disclaimer here. I'm going to describe DOCSIS 1.0 and 1.1, which came out in 1997 and 2001 respectively, and I'm describing the North American versions. There are European versions. You guys like to do things a little bit differently. I get it, it's fine. And I am a layman. I'm going to describe this in layman's terms. I am not a physicist. I'm not an electrical engineer. I am not a networking engineer.
We need an engineer. I'm an engineer.
I am just someone who really recalls feeling the gates open when I got this exact modem. And I was able to get on the internet and surf comfortably and play video games with my friends and download whatever I wanted. And I'm trying to relive that and sort of unveil the black magic that is in this box.
I'm an engineer.
DOCSIS, of course, became more sophisticated over the years. In fact, the modem in my house has a 1 gigabit uplink It is a DOCSIS modem over coax cable. So hopefully this explanation will be a good enough analogy and give you a basic idea of how these things function and what they're up to. That's the whole goal. Don't study for your test with this. You can think of a coax cable as a pipe that can be divided into different sections for different uses. In the case of DOCSIS, we have two sections, an upstream section and a downstream section. The downstream is data coming from the router to your computer. The upstream is data coming from the computer out into the internet, so upload and download. These sections of the coax pipe, as it were, are divided into frequency ranges. In the case of the upstream, it's between 5 and 42 megahertz. In the case of the downstream, it's between 54 and roughly, let's say, 1,000 megahertz. What this means is that with the right equipment, you can have an upload and download stream flowing through this single pipe, if you stick with my analogy. And so that's basically the idea. TV, VoIP, all sorts of stuff can be flown through this over different frequency ranges. And in the case today that we're worried about, DOCSIS, we've got the upstream 5 through 42, the downstream 54 through about 1,000 megahertz. Now, behind the scenes, of course, it is much more complicated than that, but that doesn't really matter. For the sake of understanding how this works, we can divide this thing into multiple streams, up and down, and then we can start taking advantage of our coax lines on the back of this router. Their labels might make a little more sense now. So you can see we've got DS0 here. Ports on most Cisco equipment start with 0. So this is our first downstream, DS, downstream coax connection. And then hiding over here, we've got US0, upstream 0, our first upstream connection. To build our ISP today, we'll be taking advantage of downstream 0 and upstream 0. But you might be noticing over in the corner here, we've got downstream 0 RF. This is the trick this particular router has up its sleeve. So a lot of these UBRs, universal broadband routers, they're just going to have a DS0, and this signal is not actually strong enough to plug right into some cable modems. You need something called an up converter, and they're very expensive. This one has a built-in up converter that will basically take whatever's coming out of here and make it strong enough for the modems to use. Again, we're staying in layman's terms here, but basically this is the one we're going to use because its strength is being increased. This is what's called an intermediate frequency coming out of here. This is a RF radio frequency. We're not going to worry too much about that. Long story short is if you're buying one of these and you want to copy what I'm doing, you're either going to need an up converter or you're going to need one that has a built-in up converter that can get RF downstream output like this. At this point, you're probably thinking, well, that's all well and good. We've got upload path, we've got download path, but we've got two physical coax wires here, and we clearly only have one connection on the back of our cable modem. Well, that's where a diplex filter comes in. A diplex filter can basically combine two different frequency ranges onto one common wire. Here we've got the upstream on the left for uploading. That was a lower set of frequencies. And then on the right, we've got one that can handle our downstream. Remember, that was over 54 megahertz. But before we can use this thing, we need to introduce some attenuators. Attenuators reduce the power level of the coax flowing through them, which is ironic because we just upconverted our downstream. You gotta remember, this thing is built for like heavy duty ISP use, potentially. And so you would have hundreds of devices and tons of splitters that would just naturally be losing power. And here I'm just in my basement with like two of these little modems. Clearly in the Cisco documentation, you need to introduce 40 dBs of attenuation on each side. And I'm doing that by combining two 20 dB attenuators. All you need to know about this is it's just reducing the power level a little bit to make it safe for the modems because my network is so small. With everything hooked up, let's bring it all together. The upstream line coming into the diplex filter, the downstream line as well, coming out on this common wire. We can now plug this in to a cable modem and it can take advantage of both the upstream and downstream sections. They've been put onto this one wire, if that makes sense. And believe it or not, it gets a lot more interesting now. So let's fire this router up and get it configured. We've got everything hooked up here, all the coax, we've got the local console cable, we've got the fast Ethernet port on the router going into my home network for internet access. And once I walk through the configuration, we'll plug this modem in and I'll show you what it does. To Cisco's credit, they wrote an incredibly detailed 188-page configuration guide for this series of broadband routers. And one section is typical routing configuration for high-speed internet access. And it actually contains the entire configuration you need to get this thing working with some cable modems. To be completely honest with you, I just copy and pasted the important looking parts of that sample config, and it kind of just worked. Here, I'm going to do a show controllers cable. This thing only has one cable controller, and we're going to look at the downstream information. The example doc happens to have set our downstream frequency to 851 megahertz. Remember, we just need 54 to about 1,000 for these early DOCSIS standards. And if we go ahead and take a look at upstream, we get a lot more information because I have more than one upstream port, but it is set to 37 megahertz. That's just what the example uses. Remember, it just needed to be between 5 and 42 megahertz. So that makes sense. You configure each upstream and downstream port to operate on a frequency that's valid for the DOCSIS configuration. I'm doing a show run to look at the router configuration, and I'll walk through some of the other interesting bits. I've defined something called a cable config file. It happens to be called Platinum because that's what the example used. I'll walk through that in a second. Basically, what happens is these modems come online and they provision themselves from the router. So over TFTP, this configuration file is actually sent dynamically to the router. And you can configure things like the maximum upstream speed they're allowed, the maximum downstream. We'll turn that off later when we do some speed tests. But basically, these things provision the modems dynamically. Another aspect is this idea of a DHCP pool. So I've created one called Cable Modems. When a modem tries to connect over coax to my router, it's going to use all this information. So it's going to get served to that boot file, that platinum.cm boot file with all the max up and download speeds. And then there's a bunch of different DHCP options. That's how the modems actually communicate back and forth with the router. I'm going to talk through that in a little more detail, but the only other thing to note here really from the config is I've done NATing. I've got network address translation going on that fast Ethernet port. And that basically just lets Ethernet traffic from the cable network that's on one subnet talk to the subnet on this interface, and that gets it internet access via my actual home network. Now, if we take a look at Cisco's example config, theirs is a little more sophisticated. I only copied just the minimum I needed. You can create pools that are tied to an exact modem. So for example, they're actually setting up a special pool with a static IP. It's getting a different boot file, so you might give different modems different speeds, like someone's paying for higher speeds. And this one is tied directly to this MAC address that they've set. If you've ever bought your own cable modem, you know you need to actually tell the cable service what the MAC address is on the back. And that's because behind the scenes, probably not some guy sitting here at the terminal, but they are provisioning your modem, its exact MAC address, and giving it all the different configuration settings that it deserves based on, how much you're paying the cable company. And of course, you can disable a modem. So they've got these examples of a modem that basically when it gets online, it's not allowed to do anything. My configuration here is a lot simpler though. You see, you don't see any MAC addresses. Basically, any modem that gets on that coax cable is going to get served these settings, which means we can actually, hook up multiple modems on that cable with splitters, and we'll do that later in the video. All that back and forth I was talking about, the DOCSIS standard defines how these things are interacting together. So we're going to power this thing on, and what it's going to do is a ranging operation. It's going to start looking on the downstream frequencies and trying to find a router that's going to respond to it. So we'll flip this on. And the lights are coming up. So it's going to go through its little boot process, power's blinking, and eventually it's going to start ranging along the downstream line, trying to find one of these guys that's going to respond. And then they're going to talk back and forth about what the upstream speed is. It's going to literally download that configuration file I showed you and be provisioned and know which IPs it should be serving and so on. And we can see we have cable connectivity right there. Let's go look at a computer that I've got this thing plugged into. The Ethernet jack on the back of that modem is going right to this Windows XP VM. You can see we've been served an IP from my network configuration on the router, and we should be able to ping out to the internet, and we can. So maybe a little anticlimactic with all that buildup, but what you just saw is what I did the first time, and that modem just works, which is incredible. Back on the Cisco router, a very useful command is show cable modem, and you get all sorts of information about the modems that happen to be connected, the IP address they're using, their MAC address, what their state is, online, offline. Pretty useful. So here's our guy that we just powered up, operating perfectly. But all is not well. I've got a couple more cable modems This Linksys unit, probably the same vintage as that one. And then I've got a much newer, I think it's a DOCSIS 3.0. Yeah, DOCSIS 3.0. These are not happy with this configuration, so we have a little work to do. I'm going to get this in the other room, and then we'll get a splitter in here, start hooking these up, show you what they're up to. Got that mess all hooked up in the other room, teetering on top of my dial-up setup. Here at Collab Retro ISP, we can meet all of your internetworking needs. Back in here, we've got our ISP coax line from the other room coming through into a splitter, which is certainly something you can do because we want to get multiple modems online at the same time. In reality, you know, like in your neighborhood, the coax line is getting split many, many times and repowered and all that. So this is definitely something you can do. Over here, we can see Old Faithful here. Online, happy, no problem with the cable connection there. But the Linksys here is just going to sit like this forever. DS, downstream light, blinking. It's ranging and looking for a downstream to lock onto, and it can't find one. Now, if we do a show cable modem, we don't see anything at all about that other one. This is that RCA unit we were looking at earlier, and you can turn on a lot of different cable debugging settings. I tried all of these. Nothing ever came through. No indication that this modem was actually trying to talk to the router. So that was making me think there's something wrong with my downstream frequency. This thing can't latch onto it. Before you get excited, it's not as simple as factory resetting it, though sometimes that is the case. These modems, once they find a signal, will sometimes store that frequency in a persistent memory, and you actually have to reset them with the buttons on the back to get them to like re-range occasionally. That's not what's going on here. A reset does nothing. So then I tried the only other modem I have, this Aris unit, this Aris surfboard. It's much newer, a DOCSIS 3 unit, but DOCSIS should be backwards compatible. This thing should be able to hook up to this older network. But of course, guess what? Just sits there looking for downstream. But this one has some tricks up its sleeve. It has a web interface we can look at. So this thing is quite a bit newer and has this nice web interface. You can see it's trying to acquire downstream channel, and it's not locked on to a downstream or an upstream. And this thing has an event log, which is kind of cool. And all we get is this sync timing, synchronization failure, failed to acquire, etc., etc. And it doesn't even know the MAC address of the CMTS. I have been calling this thing a router the whole time, but CMTS is actually the more accurate term. In its current configuration, it is a cable modem termination system. At any rate, this thing can't find the Cisco unit, so it seems to have the same affliction. It doesn't like the downstream frequency. Oh, and this is nice. It says, if you know the frequency and upstream channel that your cable modem uses, you can set it. But you can't actually set it. These are read-only. But this is an example of like once this thing locks onto a frequency, it's going to actually store it in memory so that it doesn't have to range every time. So after the better part of a Sunday afternoon, I did a little bit more Googling and arbitrarily decided to change my downstream frequency to 111 megahertz. The moment you make the change, it's live. So we are now operating at a 111 megahertz frequency on the downstream. And now if we do a show cable modem, we can see that thing is actually trying to talk to us. It's in an init cycle, and we're getting this message syntax error. So the two are not getting along. Back in the event log, we're getting a lot further. So it's saying it knows it should be using IPv4, complaining about this missing BP configuration setting, but it does have the MAC address of the CMTS unit, that Cisco router. But in the end, the Cisco router doesn't like these requests it's making, and so it just restarts and can't lock on to the downstream. So yeah, I never could get this one to work, but I don't really care. It's too new anyway, and I'm more interested in this one. We'll plug him in a second. And this guy he's already online again. I changed the frequencies on this thing, just left it online, and it just reconnects, happy as a clam. So if you're gonna do this early DOCSIS stuff, get one of these. Like, I have not been able to throw a configuration at this thing that it didn't like. But now, on to the Linksys. Let's give it some power. When it starts up, flashing all of those, that means it's just doing a little self-test. Now it's trying to lock on to the downstream. It found it nearly instantly, found the upstream almost as fast. Now we're trying to get online and get an IP, and we're done. So that was all the negotiation this thing did back with the CMTS, and we're up. Back over in show cable modem, we've got two online modems. I believe this one is the Linksys that just came online. I've got it plugged into this VM, we've got an IP, and we can ping the internet. Both of these guys are online using the same cable back to the CMTS, which of course is a pretty standard setup for how an ISP would be doing it. It's not like they're running one of these cables to each house individually. So now let's hook them up to some real computers and run some speed tests and maybe get a little comparison to just how much better even this first iteration of DOCSIS was compared to dial-up. Okay, let's have a little fun here at the end and do some speed tests with this broadband setup. And just for the full experience, I'm downloading OBS Studio, the screen capture software, with my little broadband ISP here. It is cranking away. Look at those lights go. While that's downloading, two little changes to my setup I had to do. So I'm using this kind of interesting Cisco example config where the cable interface is on a different subnet than the IPs that are sort of being handed out to the modems. At any rate, in one of the DHCP pools, I needed to set a DNS server. Otherwise, I couldn't actually use the internet. And upload just wasn't working at all. In the Cisco config, the frequency was set to 37, and I arbitrarily set it to 25. Upload started working. So let's do some speed tests. We'll start by loading google.com. And this is going to be interesting because it's going to be so uneventful. Here's a previous recording of me loading google.com over my Homelab dial-up ISP that I've covered in other videos. Well, let's go to google.com. This is real time. See what I mean? Like, this sucked. But here we are, and of course here with the broadband setup, pretty much instant, at least by early 2000 standards. All right, moving on to a speed test. See what we can get here. Not looking good. Struggling. Your internet connection is very slow. So we got 1 megabit down, 0.04 megabit up. Let's see here. I ran that a couple more times. I saw as high as 9 megabit download, which is what I would expect, because remember in our little service config file that the modem downloads, we've really limited the upstream and the downstream was capped at 10 megabit. I would have expected a little more of that. So what we're going to do is put all the theoretical max values in here, courtesy of ChatGPT here. Okay, I think we'll have to reset the modem. Uh-oh. Service temporarily unavailable. I broke something. Reject. All right, it doesn't like that config.
We need an engineer.
Okay, it's back online. It did not like that config. Let's go with something a little more tasteful. Max upstream 5 megabit, max downstream 30 megabit. Let's see where that gets us. We weren't even getting our limits here though, so I'm sure it's just tons of configuration headaches I would have to dive into to speed this thing up. Just wanted to point out, I reset the modems between config changes so they pick them up fresh from the server. I think there is a way to remotely provision them and force them to grab the new config, but I've been resetting them just for good measure. Moment of truth. I am not holding my breath on this one because we weren't even hitting... Whoa! I take it back. Look at that. Yes. We're still... I mean, now we're hitting our previous max thresholds that had been set, but yeah, this is way better. See where upload ends up. Hell yeah, your internet speed is fine. little does Google know what's going on down here. Yeah, 10 megabit down, half a megabit up. I'll take that all day in 2002. Lay it on me. Well, there you have it. Early 2000s broadband in my home lab. It makes me so excited to see this RCA modem doing stuff. Just brings back so many memories. When I was messing with that config and it broke briefly just then, I'm pretty sure it was the max burst being too high. I kind of lowered that and everything got back under control. Now these obviously aren't operating at their theoretical maximums. I'm the kind of guy that, like, once I know something's gonna be possible, I sort of lose interest and move on to the next project, unfortunately. So I don't know that I'm gonna sit down here and tinker with these to get them over 10 megabit. I would have been happy to have 10 megabit for a very large portion of my life, let me tell you. But I'll probably expand the whole coax setup over time, you know, get some TV going and VoIP, and you know, there's all sorts of stuff we can explore here. I thought this was going to be way harder than it was. That Cisco config was really almost on the money. It would have been a little easier if I had like spectrum analyzers, and so you can actually see what these things are struggling with. You know, there's more professional debug tools you could dive into. One such tool is this thing. It was not clear to me that this was going to be in the original box when I bought it on eBay. Let's get this thing opened. This is a Cisco UBR 904. This is a cable modem that's actually running iOS, you know, the same software that the big router is running. So you can get this thing plugged into your cable network and actually enable client-side, modem-side debug logging. Remember, I was showing you there's a bunch of debug logs on the router, but if the modem can't even reach the router, you don't know what's going on. This thing, I think, is capable of logging a ton of stuff about why it can't, you know, lock onto a downstream link, for example, which of course isn't going to be possible in a consumer-grade router that isn't managed and isn't running iOS like this big thing. This literally just showed up as I'm editing this video. So of course I didn't get to use it, and in the end didn't really need it. I got those 2 modems working, but this will be fun to dive into in the future, and if I ever need to troubleshoot my broadband setup, I believe this will be very useful. But I got pretty lucky, I think. I was able to get this running right off the bat, and this one down here is a very flexible modem. I hope you enjoyed this journey. I know it was a lot of talking, but it was really fun to figure this all out. This was such a black box to me, and I never would have imagined that this is something I'd be able to do myself, just with a little bit of equipment. It's been a really fun journey. If you like this video, please consider subscribing. I've got more on the way. And if you'd really like to support the channel, I'm on Patreon. I try to post behind the scenes type videos, pictures, sneak peeks of what I'm looking at, and the occasional early release video. Thanks so much for following along. Hope I see you in the next one.